So now we're going to learn about families of polynomial functions. So families are basically just it's the same type of function almost, like they have the same characteristics, like they have the same roots, except they could have different y intercepts, which basically means that it can be stretched or compressed as long as they have the same roots. They're a part of the same family, and there's different members of the family, and those are the different functions with the same x-intercepts but different y-intercepts, and I guess so, meaning that they would have different values of a, which means that it's transforming it. So this is kind of like the definition, like by the book, so you don't really need, this isn't super important, but if you want to know, it usually takes the place of this form: y equals a, and then in brackets x minus s1 x times x minus s2 times x minus s3, and so on to x minus s of some number. And a can be any real number, but it cannot be 0, because then the entire thing would be equal to 0. And given that the zeros of this function are all going to be like s1, s2, s3, those could be random numbers. But so yeah, that's basically what it means by the definition. But let's like apply this knowledge to like an actual question now. So let's say that it says that there's a family of quadratic functions have roots 2 and -3. So you know that quadratic means that it's going to be degree 2, because it's quadratic. And then right now we've got the zeros 2 and -3. So this means that y will be equal to any value of a. Then we're going to have x minus 2. That's one of our roots right there. And then x plus 3. That will be the other root right there. So that's literally it. That is the equation of a family of the function. So another member of this family would be, let's say, y equals -2 x minus 2 x plus 3. That could be a member of this family. So this here is the family. And then this one would be a member. And then this one here would also be a member. Let's say this could be 10,000 x minus 2 x plus 3. This would also be a member of the family because it's just stretched by a whole lot. It has the same roots. So let's say that we wanted this function, but let's say that the function is a member of this family, but it has a y-intercept of -10. Y-intercept is -10. So if you were to write this as a point, it would be 0, -10, because this is our y-axis. This is our x-axis. If this is a point, our y-intercept, x is 0, and y is going to be lower, like whatever that is. So this is our x, this is our y. So we could sub these points in and do y is -10. So we know that -10 equals a, and then x is 0. So 0 minus 2 is -2. 0 plus 3 is 3. -10 equals -6a. Isolate for this, it's going to be 10 over 6. And that's our answer. So a member of this family with a y-intercept of -10 would be a value of 10 over 6, and then x minus 2 x plus 3. That would be the member. So let's do another one where it says that we've got zeros of positive and -1, 2 plus root 3, and 2 minus root 3. and it's a quartic function. These are all the zeros that we have. So we know that it's going to take the form, it's basically factored form, y equals a. This is for the family. And we know that we've got x minus 1 and an x plus 1, right? That's these two. Oh, hold on, I forgot the 1. That would be these two. And then these ones are a little bit of the tricky ones, but if this is our x, then we're just going to do minus that. So it's going to be x minus 2 plus root 3. Then x minus 2 minus root 3. So we've got that, but let's say that we want a simplified, because you can definitely simplify this. So to get the most simplified expression for this family, we would do y equals a, and then x minus 1 and x plus 1, that's a difference of squares. So you could actually write that as x squared minus 1, right? Because if you were to break this up into different squares, you get these two. So now this is a little bit of the trickier one. So now what you could do is x minus 2 plus root 3, and then x minus 2 minus root 3. But you could actually put brackets around these two, because these are just adding and subtracting. Because technically these would be in brackets in the first one, but it doesn't that matter. Since we're just adding and subtracting them, we can move the brackets around. So now we could FOIL these two, and then instead of foiling the entire thing, like the x times the x times the minus 2, and then doing it all a super long method, just by simply moving the brackets, we can save so much time, and we can just do x minus 2 times x minus 2 is x minus 2 squared. So we can actually just do x minus 2 squared. This is all in brackets. And then that's going to be, well, what's root 3 times minus root 3? That's going to be minus root 9, which is going to be minus 3. Which is minus 3. And then that's going to be in the big brackets. Y equals a x squared minus 1. And then this looks like it's pretty simplified, except I'm just going to expand this and then simplify that once more. So it's going to be x squared minus 4x. And you could, if you need to, you could break this up and do the entire thing, but I'm just kind of doing it mentally to save some time. Minus 3. So that's what this is. Well, this is this part, and then the minus 3 there. So then y would be equal to, finally, x squared minus 1, and then this would be x squared minus 4x. 4 minus 3 is plus 1. So if I were to factor this fully, then I would actually end up with what we got in the original, but we're just simplifying this. So our answer would be this. This is the family with these zeros.